Hi guys. Hi, unanisikia? Amos, ni aje? Okay, so let's allow wenye wanaingia waingie and then we start. Tuwape, let's give them 5 minutes. We start at 8:15. Hizo ni 8 minutes. Okay, so I think I'll start. My name is Denzel Abele. I'm the blockchain lead. Today, I will be taking you through the introduction to blockchain. So, I hope you can all see my screen. Somebody, anybody, say something in the chat. Okay, with the confirmation of Victor, I think I'll start. Okay, so first of all, we'll start with the evolution of the web. We talked about this. Those who are in the meet on Saturday, I gave a brief overview about this, but I'll just repeat. So the web has evolved as we know it from Web 1 to, and now we are venturing into Web 3. Web 3 is where blockchain comes in. So Web 1 was basically a library of static read-only pages where you could only go and consume information, but you could not interact or contribute to the website. Then came Web 2, which was the read and write web. So this Web 2 introduced interactivity and user generated content. Users could now generate content and post on the web. But then this came with the cost of centralization, since the users created value while platforms own the data. For example, we have corporate silos like Google, Facebook, which have a lot of user data. So you find that the system is too centralized in such a way that in case of anything with the servers, the whole system can crash. So Web3 came as the decentralized web now. It is the new paradigm of the internet, powered by the blockchain technology and smart contracts. It is permissionless and relies on a decentralized network. So Web3 basically came to solve the problem of centralization mostly. Okay, so we move on. So when I talk about Web3 and blockchain, I hope you see the difference. In the previous slide, we saw that Web3 actually functions, it's actually powered by the blockchain technology. So Web3 is powered by the blockchain technology, and then we define the blockchain technology itself. So the blockchain technology is defined as a decentralized and immutable public ledger that is updated and shared across distributed computers, also known as nodes in a network. So basically, uh, it's called a blockchain because data is stored in blocks. For those who are proficient in computer science and probably applied computer science, you've learned about data structures. So blockchain uses the concept of linked lists. I'll explain it this way. Data is stored in blocks. So each of this block contains the data itself, the data that has been stored, a hash key for the block, and the hash key of the previous block. So I will illustrate later on in the lesson how this comes to be. But you need to understand that data is stored in blocks, and then these blocks, they contain a hash key for the specific block and the hash key for the previous block. So the hash key for the previous block inside the block is the one that enables the creation of a chain of blocks. That's the name blockchain. So for those who have done computer science and data structures, you understand how the linked lists actually link and how data is stored in linked lists. It's the same. So in a linked list, you have the data, you have the address of the next node and the next address of the previous node. So a block stores data in the same way. So once a block is created, a hash key is calculated. The hash key of the specific block is calculated, and thus changing any data inside the block will lead to changing sorry changing the entire block rather. So I want to show you this practically. Just a minute. Okay, so let's come here. I hope all of you can see my screen. So this is a website called undersworth.com. I'm typing it on the chat. Anders Brownworth. So as you can see, it's just a simple preview of what happens. So this is the hash. First of all, you can see the area data, it's actually blank. So hata ikiwa blank, there's still a hash key down here. So you see when we change, for example, we write, you notice that the hash key changes. And then the hash key changes every time you change even a single detail. For example, we change this G to D. You see the entire hash key changes. So that's how blockchain brings in the aspect of immutability now. So when you change, remember this data is inside the block. So when you change even a single detail in the data, the hash key that is being produced totally changes. So you find that when you change even a single detail in the data, the hash key changes. So this means that this is a totally different block, because this hash is the identity of a totally different block. So I hope you understand that. So you see the empty data has E3B0. When I input some data, maybe input my name, the hash totally changes. And the hash changes even when I change even a single character, as you can notice. Yeah. So that's how hashing happens. That's basically what happens when hashing. So I'll also explain about block, how the block analogy works. So as you can see, this is the block. This is how a block looks like. So it has a number, a block, the block number, which is 1. So this means this is the first block on the blockchain. It also has a, a data section over here, as you can see, and it also has a hash key. We call it a hash key. So a hash key is generated after data has been encrypted. So it it encrypts even the empty data. Like hata kama hakuna data, there's still encryption that is happening. So when we put data in here, we alter the data in here. For example, I put my name, or we put GDG. You notice that the hash of this has changed. And then we have, you notice that we have this nonce, this number, the nonce. So basically what the nonce does, the nonce is actually the one that is used to calculate whether, to verify whether the blockchain, whether the data in the block has not been tampered with. So to come up with this hash, there is a hash function or a hash algorithm. This is the algorithm that the function or the algorithm that computes data into a unique hash. So the nonce, when we talk about, I will explain about the nonce when talking about the consensus mechanisms and how the nonce is used to actually actually mine blockchain, mine Bitcoin, sorry. So now we move on to the practical definition of how a blockchain actually works. We've seen how a block works. Now we have to see how a blockchain works. So in a blockchain now, as the definition suggests, we see a few parameters over here. We see the number of the block. We have the nonce, which I said I'll explain. And then we have the data, we have the actual data, and the hash. This is the hash key of the previous node, of the previous block, sorry. As you can see, it's 000 because there is no previous block. This is the first block. And then this is the hash of this block 1 itself. When we go to block 2, we see this is block 2. It has its nonce. It has the hash of the previous block, as you can see. So this is the hash of the first block. And then you see this is the same hash over here. And then this is the hash of now of block 2. So this blockchain has a total of 5 blocks, as you can see. And I want us to prove the definition of a blockchain, that a blockchain is, first of all, I want to prove the aspect of immutability, and then I will later on prove the aspect of immutability. So on the aspect of immutability, let us come to this distributed section here. Now this is the description. It's the description that shows how a blockchain actually is. So we have peer A, peer B, peer C. So peer is the same as node. So these are nodes. These are actually nodes. This is the first node, the second node, the third node in this blockchain. So as you can see, the blockchain itself. This is the blockchain itself, and you'll notice that it's the same. It's distributed among the nodes. So block A, node A, block 1 should be the same with node B, block 1. So as you can see, the nonce is the same in this node 1 and the same in this node 2, the nonce. Also the hashing, they're similar. So the aspect of immutability comes in when I try to, for example, alter the data in block 2. For example, let's put GDG in block 2. So what will have to happen, you see, when I alter the data in block 2, all these other blocks will have an issue. This is because when I change the data here, the hash of this block changes. So the hash that block 3 recognizes as the previous hash will not be the same hash that's here. So that's a broken blockchain. So that means that the blockchain has broken from here up to number 5. Because when I change the data here, I'll have to remind the block. When I remind this block, it gives me a totally different hash. And this was not the initial hash that was here. So, for example, if node A tries to alter the data in block 2, it will just be noticed, because even if block node A reminds the block 2, it will have a different hash, but the hash will not reflect in node B block 2, as you can see, or node C block 2, as you can see, sorry. So you notice that when one node tries to actually alter the data in the blockchain, the other nodes can actually refute and say that node A has tried something malicious on the blockchain. So you can't actually hack a blockchain for this reason, because remember, the blockchain, the nodes are actually distributed. So you can find one node in Kenya, another node in Sri Lanka, another node in China. So there's no way you can manage to convince somebody in Sri Lanka to alter their data for you so that you can do some malicious activities. It will be difficult because you don't know each other. So in this sense is how blockchain maintains its sense of immutability, such that no data can be altered. So you can visit the website and play with this data here. There are also videos on the website that will explain in depth about what's actually happening here. So let's try to now see blockchain with a bit of data. So as you may know, blockchain, the first okay, let me just do this. Okay, as I was saying, blockchain was first popularized by Bitcoin, and Bitcoin was a solution, a financial solution that came as a result of wanting to reduce or remove the central authority or human trust in terms of finance and all that. So Bitcoin was actually the first flagship of the blockchain technology. Okay. So Bitcoin functions as a store of value and allows for peer-to-peer transactions without the need of a central authority. Let's go back to the demo. So in the screen, we can now see the practicality of a blockchain in solving the problem of centralization in financial transactions. So we see that block number one was actually a transaction from block number one has the following transactions. So the transactions in this case will be the data in the block. So this is the data. As I remember, as I began, I said a block has the data, the hash of the previous block, and the hash of the next block. So this is the data that is in the block. So if at all I try to change the data in this block, so maybe let's say we remove this, we change this 88.32 to 8.32. You see, you notice that the color of these other blocks of the next consecutive blocks actually turns to red. You see? So this is what actually happens when you try to change the data in a block. So this will be different. So when you mine this, when you remine this, the hash the hash changes, but then you will have to mine all the other three all the other three consecutive blocks that follow. And if you know the concept of mining, we will talk about it in a few. Mining is quite expensive, especially for protocols like blockchain, like Bitcoin, sorry. Protocols like Bitcoin, mining is so expensive. So if at all you want to mine the blocks, the three, four, five, the three blocks, in order to, it will be expensive. And then still, if you manage to mine them all, which is close to impossible, the other nodes in the blockchain will refute. This is because the hash codes or the hash key will be different. So if at all you manage to mine all the blocks, then the node in the node B will have totally different hash functions. So you will be kicked out of the blockchain for trying to tamper or alter it. Or in the case of Ethereum, which uses proof of stake, you will be slashed some of your stake. Speaking of that, let us talk about the consensus mechanisms. Okay. So we have the consensus mechanism. So as we have seen, the blockchain is a distributed database or a ledger that records data and allows users to exchange and store value in the form of cryptocurrency. So Bitcoin is a form of a cryptocurrency. So to coordinate and maintain such a decentralized system, since we do not have a centralized authority, the participants must agree on the correct of condition of the system and who owns what resources at any time. So this is why they came up with the consensus mechanism. So the consensus mechanism is the standard way or standardized way of how the blockchains node reliably reach this agreement. So we have two major types of consensus mechanism. The first one is the proof of work, and then we have the proof of stake. So in proof of work, uh, The consensus requires a significant amount of energy, hardware, and computing power to propose a new block to the ledger. This is the one that Bitcoin uses. I don't know if you've ever heard about Bitcoin mining. If you know about Bitcoin mining, you know that it's expensive since it requires a lot of energy. The people who are mining Bitcoin in Kenya are there are a few individuals who are mining, like a company called Gridless. Gridless are mining Bitcoin using HEP power in a river in Murang'a. So you can imagine how expensive mining a Bitcoin is. So the nodes that validate transactions and propose new blocks are called miners. So miners compete to generate a random number to unlock the next block on the chain. So you see this random number that the miners actually try to generate. This random number, this random number is the one that is compared to the nonce, as we had seen in the Undersworth website. So they generate this random number. So this random number is supposed to be equal to the nonce. So when the random number is equal to the nonce, then the transaction has been added to the block successfully, and that is in Bitcoin mostly. In Bitcoin, the quickest miner to reach that number adds the next block, and in exchange, the miner receives a block reward. So the block reward is constant. It's usually constant, but it has been halved. It is since the beginning of Bitcoin in 2008. There has been halving of that reward. So I don't remember the first reward, but right now I know it's around 1.125 Bitcoin. That is the reward. But since the last halving happened in 2020, and 4 years, it usually takes a period of 4 years before Bitcoin halving happens. So 4 years before 2020, it was twice 1.125. That's around 2.25. And then 4 years before now, 2016, that's 2012, it was around 4.5 Bitcoins. So when you mine when you manage to add a transaction onto a block, and then it's added to the chain successfully, then the block reward was 4.5 Bitcoin in 2012. Yeah. So the only way to win is to generate random numbers as quick as possible. So this is the work. It's actually very intense work. So it actually takes a lot of computational power and energy, since it uses some special computers. Miners are not just normal computers, they are special computers, especially large scale mining, Bitcoin mining. So that is a contest of computing power, which in turn requires hardware and electricity. So that is all for proof of work. It was the first consensus mechanism, since it was the one that was used by Bitcoin. So later on, they saw that since it requires so much energy, so definitely it means that there's also so much energy being wasted to the environment. So they decided to, when coming up with Ethereum, the founder of Ethereum, Vitalik Buterin came up with another mechanism which was a bit easy on the environment. So the mechanism was proof of stake. So in proof of stakes, the nodes that verify transactions and propose new blocks are called validators. So validators are required to lock up a certain amount of value in the form of the blockchain's native token. So if it's Ethereum blockchain, they use the Ethereum token. If it's Bitcoin blockchain, they use the Bitcoin native token. If it's Avalanche, they use the AVAX native token. So the more value of the more value a validator deposits, the bigger the chance they have to propose a new block and earn the block reward. If a validator commits an error, they have to pay a fee or can be excluded from the validation process. So we see that in this case of proof of stake, it's simply staking, then validating. If at all you try and make an error like we saw in the Undersworth website, you are removed. You can be removed, excluded from the validation process, or a fee can be taken from your stake. Yeah, so those are the main two consensus mechanisms, but we have more which you can check on during your free time. We have proof of human, we have proof of stake, but now this one is determined by your history, by how 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 many how trustworthy are you in the network. So the most trustworthy validators are given priorities over the least trustworthy validators. Yeah, so that's it about the consensus mechanism. You can check for more because there are so many right now. In the world of today, there are so many, but these are the main two. The most of the current consensus mechanisms actually stem out of these two. So, but you can go and check on them. So next, I will take you through. We've talked about Bitcoin, Ethereum. Let's talk about smart contracts. So we've talked about Bitcoin being trustworthy, being immutable. We've talked about Bitcoin having no authority. We've talked about being immutable. You can't change data after you've deployed on a blockchain. So we've talked about many things. So how does the the blockchain actually achieve this? The blockchain achieved this through smart contracts. And smart contracts are self-executing programs on the blockchain that automatically carry out transaction when specific conditions are met, eliminating the need of a central authority or intermediary. So, as we will let us see on in the series, as we continue to learn, we will see how to write smart contracts and how we write the statement when specific conditions are met. These are just functions. Anyone who was actually programmed before, you understand that these are just functions that are being put. You can just code a function so that a transaction occurs when a specific condition is met, when a specific condition is met. So when writing smart contracts, you will realize that you actually write the script to deploy the smart contract. You write tests to test whether your smart contract is okay. The process is called auditing. You test to see whether your functions are actually functioning well. Basically, all these will be put inside the smart contracts. So the features of the smart contract include they are transparent, they are fast and efficient, since you can actually send a transaction and it will immediately reflect on the recipient, depending on the conditions and the block confirmations that will happen, the number of block confirmations that will happen. So the block confirming is actually a security measure. Block confirmation is the process in which blocks are added onto a certain block in order to prevent data being manipulated from the block. So what do I mean? For example, we have block one. So the data has already been inputted into block one. And then the block has been validated successfully. So the miner has generated the random number, and it has successfully equated to the nonce. So after this happens, whether when you kama ushaifanya transaction hapa, you usually see that 1 out of 23 block confirmations. So what that actually means is more blocks are being added onto your block, onto the block that has the data of your transaction. So the more blocks that are being added to the blockchain, the less vulnerable it is being attacked. And maybe I can show from the demo. See, what I'm saying is your block is block one. You've sent or you've received 25. Let's say Darcy is sending $25 to Bingley. So this is the transaction data in block one as it is. So once this data has been mined, has been added, has been confirmed successfully, once the miner mines this, and then the nonce is actually equal to the random number that the miner will generate, the data will be added to the block. So block confirmations basically means waiting for this other data in this block to be validated and added to the block. For example, if the protocol that you're using uses 5 block confirmations, you'll have to wait for 5 other blocks to be confirmed and added to the blockchain in order for you to say that now you've completed your transaction. I will show you this demo during our next class. How you send funds from a wallet to another, and how block confirmations actually work practically. So that's basically it. When you think of block confirmation, when you see block confirmations, just know that more blocks are being added onto your block in order to avoid your block being manipulated by malicious actors. Okay, features. We talked about this. Applications of the smart contracts. We have decentralized finance, which allow users to engage with financial markets without relying on centralized intermediaries. We have decentralized autonomous organization. These are applications that are governed entirely by smart contracts, and of course, they're decentralized. We have NFTs, non fungible tokens. This is the unique digital art. I was telling the people who are in the info session on Saturday about the coffin meme. Those guys, when they trended during COVID, this guys hizi zenye mtu anaanguka, and then you see the coffin guys dancing. Ting, 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 that one. So they actually turned that video into a unique digital art, and they sold it for more than $1 million. So you can just find a photo, a unique photo, or you can make a unique photo and make a hype out of it and sell it for ridiculous prices. Yeah, so those are some of the advantages of knowing how to write smart contracts. Okay, let me talk about public private key cryptography. So, in public and private key cryptography, the public key and private key work together to ensure the security of the exchange data. For example, the data is of a transaction between Jane and Bob. So the public key work and private key will work together to ensure the security of this data. So a message gets encrypted by a public key. The public key is the one that is available to everyone, and it is only decrypted with its unique private key, which is only available to its owner. So only the owner of the private key can actually see the private key. And for those of you who have wallets, make sure to never disclose your private key. Nowadays, they come in the form of mnemonics, 16, mostly 16 to 24 words. Just a minute. So, here, the only thing that I did not mention is that the wallet address is usually derived from the public key. For those of you who have actually done a cryptocurrency transaction, you realize that you have wallet addresses, and when you try to make a transaction, you have to sign the transaction using your private key. So for modern devices, you can use your biometrics and all that, but you have to use your private key. So, for example, if you create a wallet, you will be given 16, they're usually 12 to 24 words as your seed phrase or your mnemonics. So these are the ones that you use. This is your private key, and this is what you use to decrypt your public key. So with that, my session comes to an end. That is basically the overview of the blockchain technology. Uh, there is so much to it, but that is what I can summarize it to. So before our next class, our next session, you can look at layer 1 and layer 2s and how they interrelate. You can find out some of the programming languages that are used to write smart contracts. We will be using Solidity and the Ethereum virtual machine. So you can find out more languages and see whether you can actually learn them. So also need you to read on the common blockchain attacks. There are not many. Just go through them and understand more about them. So that has been my time. If there are any questions, I will take them at this point. Questions? Amos, uko sawa? Lewis. Okay, so nimeweka a resource that you can use. Okay, no question. Okay. Hapo nimeweka a resource. It's actually a website. It's called Cypherin Updraft. So Cypherin Updraft has very nice career paths and very nice lessons on blockchain. So you can actually follow them. You can look, it's a website, just go check it out. It has amazing lessons, and also it has well laid out career paths for the blockchain technology. With the blockchain technology, you can be a blockchain dev, you can be a blockchain expert, you can be a smart contract developer, you can develop front end for dApps, decentralized applications. You can also be a security researcher. This is where you check for vulnerabilities. This is like the cybersecurity of blockchain technology. You can be what else? What else? I think those are majority of them. Oh, Lewis started on Cypher. Yeah, that's nice. Cyphering has well laid out lessons. Kindly check it out. If at all you're interested in the technology, check out Cyphering Updraft. It's very nice. So, with there not being any question, I think I can now end the meet. Ama kuna swali one last time? Okay. So thank you guys for showing up. See you on Wednesday. Same time, different topic. You guys have a good night.